Okay, so we're looking at the binomial distribution again. We're using our formula for a second time. Now, I've been really careful here not to write you a question with dice, coins, or cards. The binomial distribution is so much more than that. Anytime there's a number of trials where there is either success or failure, we've got a binomial distribution. Of course, when I was making up a question, I ended up making up a question with poop involved. It's just how my mind works, I guess, unfortunately. So I read the question first. When walking under a particular tree, the probability of a bird pooping on you is 10%. So if you walk under the tree 20 times back and forth, maybe you go past that school every day on your way to school, past that tree every day on your way to school, if you walk under the tree 20 times, what is the probability of getting pooped on exactly 3 times? Okay, so we can use our... This question is no different to cards, dice, coins, etc. There's success and there's failure. Now, first of all, I might just write a little bit of information here. Now, the number of trials we're dealing with, there's 20 trials. Now, the number of times we're dealing with is 3. Now, the probability of success, and this sounds odd here. In this particular question, success is given as getting pooped on by a bird. We don't talk about success in probability the way we would talk about it in life. Success is more like the thing that we're interested in. And in this point, we're interested in getting pooped on even if we don't want it. Now, the probability of getting pooped on here is 0.10. I've expressed it as a percentage here on purpose so you realize that you need to convert it to a decimal. Now remember that Q, the probability of failure, and in this case failure is getting under the tree without getting pooped on, is 1 minus the probability of success. So if the probability of getting pooped on is 0.1, the probability of not getting pooped on is 1 minus 0.1. 1 minus 0.10, which is 0.90, or just 0.9. Now we can use our formula. Probability x is equal to x is equal to the number of trials combination, the number we're interested in, times the probability of success to the power of the number of successes we're looking for, to the power of times q to the power of n minus x, which is essentially the number of failures we want. Now we can write all that out again. The probability that x is equal to exactly 3 times we get pooped on. There's 20 trials here, and we want 3 successes. The probability of success here is 0.1, and we want 3 successes. Now the probability of failure here is 0.90, and we want n minus x. We want 17 failures. You can always check your work here by making sure that these numbers, 3 and 17, add up to the number of trials. Because if we have 3 successes, we're going to have 17 failures. After that, it's really a case of typing all of that into your calculator. I'm going to do it step by step here. You could type it all in at once. Okay, so 20. I've already got my NCR open. 3. Okay, you can see it's a big number there, 1140. So if I have 20 trials, there's 1,140 different ways that I can have 3 successes. Really think about that and how that number could come to be. 0.1 to the power of 3. Okay, times 0.001, I think. You will end up with some small numbers like that, which is why it probably makes some sense in these cases to do this whole thing all in one line, so a nice number pops out. Anyway, finally, it's 0.9 to the power of 17. 0.16677. 0.16677. Okay, that whole thing now, 1140 times 0.001 times 0.16677. Okay, 0.19. 0.19. We'll go to 4 decimal places. 0.1. I go to 4 decimal places here because when I express this as a percentage, it'll end up being 19.01%. All right, now think about this. If you were to walk under a particular tree 20 times where the probability of getting pooped on is 10%, there is a 19% chance that at the end of those 20 trials, at the end of those 20 days where you walked under the tree, you would have been pooped on exactly 3 times. The probability of getting pooped on 2 times is probably a little higher than that, is my estimate. The probability of getting pooped on 4 times is probably a little lower than that. Now, the probability of getting pooped on 20 times is almost impossible, but there would be a small probability if you're really unlucky. And the probability of getting pooped on 0 times is smaller than this, but if you were lucky, you could probably get away with it. Okay, so this is our binomial distribution. This is using the formula to solve those questions. It's really now comes down to you practicing this stuff over and over and over again, making sure you're getting the correct answers, and if you aren't, you need to talk to me about it and see if we can fix it up somehow. All right, good luck.